So one of the issues my students have is this concept of common ancestry. What we're going to look at today is this diagram that I made for my zoology class, which is a evolutionary zoology class. What we're going to talk about today is the connection between birds and humans. We have a location up here, which is birds, and I'll put a little circle around that. We also have a little section down here, which is basically where we would find humans. So humans are part of the mammal group, and even though it looks as though mammals basically make a straight line to humans, there's an awful lot of little branches just like you see up in here. This is just overly simplified because this is a completely separate unit in the class. This unit is dealing more with the radiation of reptiles, as you can see right here. Now, if we look, we can find that we have reptiles starting out at about 320 million years ago, and relatively rapidly after the reptiles evolved, they split into two major groups. Reptiles, we have what are called synapsids and diapsids. Now, those words are scary and we're not going to talk about them anymore, but the idea is just to understand that we have two major groups, one of which eventually led to humans and the other led to birds. So, if we look at the diapsid group right here, we can see that there are two other major groups, one of which became squamata, which right here is lizards and snakes, rhynchocephalia, which are sort of weird-looking iguana-type animals, and ichthyosaurs, which are aquatic reptiles. These are not dinosaurs, but they're big and scary, and they lived at about the same time dinosaurs did. Up here in this archosaur group, we have crocodiles, which we're well aware of. Those are the scary things with big teeth that Steve Irwin was always hunting. We have pterosaurs, which are not dinosaurs. They are a group of reptiles that flew. And then we have up here dinosaurs. Good and proper dinosaurs. Dinosaurs evolved into a whole variety of different groups, one of which, however, went on to become our modern birds. So the things that are in your backyard that flap around and go tweet, those are dinosaurs. They're not just related to dinosaurs, they are technically dinosaurs. Birds have feathers, and if you look very carefully at them, they have a lot of similar bone structures that dinosaurs did as well. That's well beyond the scope of this screen capture to get into, but essentially birds and dinosaurs, same deal. Now, what we can do is we can take a look at birds and humans, and at first they're pretty far apart. There's not a lot to connect the two together. However, if we look over here, we can see that the birds right here are in red, and I'll circle the humans over here also in red so we can have a nice connection there. Humans didn't evolve 65 million years ago. They were much more recent than that. But in any case, what we see here is if we follow the bird line, we can see birds go back and are related to dinosaurs. Dinosaurs have a relationship with crocodiles and pterosaurs, but aren't either of those. So birds are related to crocodiles, but are not, in fact, crocodiles. Birds are also related to, if we go down here, all of these things as well. So if we follow birds, we can see birds are related to these. They're also related to these, although squamata, lizards and snakes, are not as closely related to birds as crocodiles are. So if you were to try to put a family tree together, you would find birds and crocodiles are much closer to one another than birds and snakes. Now, that doesn't mean they're not related, they're just further back, kind of like second cousins instead of just cousins. Now, birds, right here, you can see if we trace this back all the way here to archosaurs, to diapsids, and then eventually down that line right there, we can find it meets at that point. Humans, in the similar fashion, although not nearly as elaborately sketched out on this diagram, reach all the way back to mammals, and then therapsids, and then synapsids, and eventually back down to that spot right there. The spot where the two of them meet right there is called the common ancestor. So, about 320 million years ago-ish, humans and birds had a common ancestor, which means that there was a critter that lived right in that general spot that eventually evolved into both synapsids, the group that would become humans and mammals, and diapsids, the group that would become all of these things. So, birds, humans, connected way back there. Now, that's not the only place that everything is connected. Humans, in fact, if you were to trace all of these things, would find that humans have a common ancestor with crocodiles. It happens to be the same one as birds, but they do have a group of dinosaur, or they have a group that they're related to. The neat thing about all this stuff is that if you follow this pattern back, eventually you find that humans are not only related to birds and pterosaurs and ichthyosaurs, etc. Humans are also related to everything from squirrels and chipmunks to whales and oak trees, bananas, and things like that. So common ancestry is a very complex concept that's very important for beginning students to understand, and hopefully this screen capture here will allow that to happen.